Welcome to Lecture 5. In this lecture, we'll explore the exciting world of text mining, turning raw text into meaningful data. From crawling live news to analyzing sentiment, this is where coding meets language. Let's start with a big picture views. What is text mining, why it matters, and where it's used in the real world. You'll soon realize that words are data too, and powerful ones at that. Before diving into code, we need a solid foundation. Let's define what text mining actually is, use a memorable analogy, and break down the process into digestible steps. Think of text mining like sifting through thousands of documents looking for gold nuggets. We use code instead of a shovel. Let's talk about the why. Why do we even bother with text mining? Spoiler, there are business research and everyday uses everywhere. In a world full of noisy text, text mining helps us listen smarter. It transforms unstructured chaos into structured insights. Once you start looking, you'll realize that almost everything around us is text, and it's all analyzable. Text isn't like numbers, it's messy. Let's look at what makes text data tricky to work with and why preprocessing is a must. Text is full of hidden landmines. Cleaning and normalizing it is the first real superpower you'll learn. Here's our roadmap for the rest of the lecture. We'll follow this pipeline step by step, and you'll get hands on with every part of it. Welcome to part 2. In lecture 4, we explored the core tools of web interaction, requests for static pages, and Selenium for dynamic ones. Now, we'll put those tools into action. Think of the internet as a massive forest of information. Our mission: to build a smart little robot, powered by Python, that can navigate this jungle, find the exact berries aka data we want, and do it efficiently and politely. We're not here to break into websites. We're here to understand how to request, retrieve, and respectfully collect the data we need for text mining. Let's get crawling. Let's start with the basics again. Web crawling isn't hacking, it's just a super smart copy pasting automated by Python. You're not breaking in. You're ringing the doorbell and taking notes politely. Crawling is like training a robot intern. You teach it where to click, what to copy, and when to stop. It won't drink your coffee, but it will definitely work through the night. Before we send our robot out, we need to speak the language of the web. That language is called HTTP, like polite letters between your browser and a server. Every time you open a website, your browser is saying, "Dear server, may I please see your homepage?" It's digital etiquette. This is your very first handshake with the internet. We're asking the server, "Hey, can I see your homepage HTML?" And yes, it's that easy. Let's peek under the hood. HTML is the skeleton, the bones of any website. Once we understand its structure, we can start pulling the data out like digital archaeologists. HTML is kind of like a Russian nesting doll. The deeper you go, the more specific the content gets. We just need to know where our data lives inside those dolls. Here's where the magic begins. Beautiful Soup is like having super vision. It helps us see through messy HTML and zoom in on exactly what we want. One line and boom, we've got readable HTML. Beautiful Soup turns spaghetti HTML into clean noodles we can slurp up with Python. Let's walk through how we identify the right HTML elements for headline extraction. Using Chrome's Inspect tool, we examined the news site structure and found that each headline is wrapped in a peto tag, not in a hetur or divi, as we might see on other sites. More specifically, these peto tags have a class name that includes the string news title. That gives us a clear signal: hey, I'm a headline. So in our code, we target all peer tags where news title appears in the class list. This ensures we only extract actual headlines, not subtitles, descriptions, or unrelated text. This is a great reminder that every website is built differently. Our job isn't to memorize tag types, but to read the structure, adapt, and extract smartly. What if your robot loads the page and nothing's there? Welcome to the world of JavaScript. We'll need Selenium, a robot that can click, a scroll, and wait like a human. Selenium is powerful, but it's like using a spaceship to go to the grocery store. Only use it when necessary. This is your robot driver. Chrome opens, your bot takes the wheel, and boom, you're in. Great for sites that hide content behind clicks. Crawlers should be polite digital citizens. Don't be that guest who raids the fridge and never says thank you. Be respectful and stealthy. Enough theory. Let's get our hands dirty. We're going to crawl live headlines from the Korea Times website. This is where web scraping gets aerial. Before we launch the mission, let's scout the target. We'll inspect the site and figure out where the headlines actually live in the HTML jungle. This part feels like detective work. Click around and look closely. Every piece of content on the web is hiding in plain sight. Time to automate the hunt. Let's write a Python script that requests the home page and extracts all those sweet headlines. This is your first real life scraper. If it prints some headlines, give yourself a high five. You've just crawled a news site like a pro. Boom, we've got headlines, real ones, from a real website, and we did it with just a few lines of Python. That's power right there. But wait, scraping isn't always this smooth. Let's talk about some common issues you might run into and how to level up your scraper. The web is wild. Sites update their layout, load content with JavaScript, or just act weird. That's why a good scraper is always flexible and polite. Let's not lose our precious data. Time to stash those headlines safely in a CSV file, because real data scientists always save their work. With this one line, you're turning scraped text into a real dataset. This file will be your starting point for text mining in the next section. Now that we have our headlines, it's time to clean them up. Think of this part as a text car wash. We're getting rid of the dirt so the machine can read it. Raw text is like uncut vegetables, healthy, but you can't throw them straight into the dish. Preprocessing is our way of chopping, peeling, and getting it ready for the model kitchen. Here's the game plan, a series of steps we'll use to clean up our text, one operation at a time. These are the 5 moves you'll use again and again in any text project. Once you master them, every messy dataset becomes an opportunity. First step, make everything lowercase and remove those weird symbols that confuse our models. Let's keep it clean and simple. Think of regular expressions like a laser cutter for text. We're telling Python only keep lowercase letters and spaces. Toss the rest. Next up, tokenization. That's a fancy word for something simple. Turning sentences into lists of words, like slicing bread before eating it. One line and your headlines go from blah 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 to habla, a blah, a blah. Much easier to work with. Stop words are like the background noise of language. The is on. These don't help us analyze meaning, so we ditch im. Stop words are like seasoning, too much and they overpower the dish. Remove them and we start tasting the real meaning. Now let's talk linguistics. Do we want to cut words down to the root, stemming, or turn them into their proper dictionary form? Slemmatization. Stemming is aggressive. It chops everything. It's fast but can be a little messy. Perfect for simple models or big data. Lemmatization is classy. It uses grammar rules and dictionaries to clean up the words. If you want elegance, go lemma. Now let's wrap up the whole process. We'll join the clean tokens back into neat little strings ready for vectorization or modeling. Look at that. From raw headlines to clean, structured, beautiful text. This is what models love to eat. Words are fun. Let's take a peek at some of the most common ones across our headlines. A quick frequency plot tells great stories. In just a few lines, we see which words dominate our headlines. Spoiler alert, Korea will probably top the list. Never forget to save your work. We've just gone through 10 plus steps of transformation. Don't let it vanish. Boom. Clean text saved. You're officially ready for machine learning, sentiment analysis, or topic modeling. This is your cleaning toolkit. Keep it close. From now on, anytime you see messy text, you'll know exactly what to do. Alright, we've cleaned the text, and now it's time to make it count. Literally. Let's turn words into numbers so machines can finally understand them. Your model doesn't understand text, it only understands numbers. So our job is to convert human language into mathematical form. Let's start with the simplest and most famous method, bag of words. It's like counting word popularity across all documents. It's like a word census. You go document by document, counting how often each word shows up. Super simple, but surprisingly powerful. Just like that, we turned headlines into numeric arrays. Each row is a document. Each column is a word. Each number is a count. Bag of words is great, but it treats all words equally. What if we could weigh words by importance? That's where TF-IDF comes in. TF-IDF is like finding the spicy keywords. If a word shows up in every doc, it's probably boring. If it's rare but intense, that's what we want. Same idea as bogu, but now the numbers are weighted. Words that are common across documents fade away. Rare ones shine! So far, we've looked at individual words. But what about phrases like North Korea or interest rate? That's where n-grams come in. N-grams let you capture context. Instead of treating words separately, you get phrases. North Korea becomes one feature instead of two. We've got numbers, we've got vectors. Now it's time to see the story behind the data. This part is where boring arrays turn into beautiful insights. Let's start simple. What are the most frequent words in our dataset? This gives us an instant sense of the dataset's flavor. These 10 words are your headline rock stars. They show up the most and hint at the dominant topics in our news feed. Boom, just 5 lines and you've created a real insight. Who said Python can't be pretty? Want to impress your friends with a single picture? Let's make a word cloud, the coolest looking visualization in NLP. This is your dataset's fingerprint, an artistic summary of what your headlines are really about. Show this in a portfolio and it's instant credibility. Before we move on, let's peek inside the vectorized data. Just how many words are we tracking? And how sparse is it? This gives us an idea of how sparsy our text data is. Spoiler, most of it is zeros. That's the nature of language. We say a few words out of thousands. Can we measure similarity between headlines? Absolutely. Text vectors can be compared like any other math vectors. Cosine similarity tells us how close one headline is to others. Super useful for clustering, deduplication, or recommendation systems. Let's give our data some feelings. In this part, we'll train our machine to detect emotional tones. Is a headline positive, negative, or neutral? Sentiment analysis is like emotional detection for text. It's what powers movie review scores, customer feedback summaries, and even political opinion. There are many libraries for sentiment analysis, but we'll start with TextLob. It's easy, fast, and works great for headlines. Each headline now has a score between 1 and 1. Negative, sad, bad, positive to happy, good, 0p neutral. It's like assigning mood scores. You can almost feel the emotion behind the numbers. Machines don't feel, but they can approximate it pretty well. Let's see how the headlines break down. Are we living in happy news or doomsday vibes? Most news is neutral or slightly negative. No surprise there, the world loves drama and disaster. It sells more clicks. Numbers are great, but humans like categories. Let's turn those scores into positive, neutral, or negative labels. Boom, we now have labeled emotions. This opens the door to classification, trend tracking, and dashboarding. Ta-da! Your very first emotion pie chart from real headlines. This is a chart you could actually show a client or stakeholder. Imagine if we could ask a machine, what are people talking about in the news today? That's what topic modeling does. And it's magic. Topic modeling is like giving a machine a bunch of documents and asking, what patterns do you see? No labels, just pure exploration. LDA is like a blender. It mixes documents and pulls out themes. It doesn't care about grammar. It just looks for word patterns. LDA needs input in a special form lists of tokenized words. Luckily, we've already cleaned our text. We're building the vocabulary dictionary and a bag of words corpus. The fuel LDA runs on. Now for the main event, we tell LDA to find, say, 5 topics, and it will do its best to group our data accordingly. Virally, you'll now see 5 topics, each represented by 510 keywords. You just built a theme detector for news headlines. What do these words mean together? That's where your human brain comes in. Machines give you keywords, you give them meaning. You're now an NLP detective. Each topic is a hidden conversation happening across headlines. You just uncovered it. If you want to impress your boss or classmates, this is it. Pyle Davis gives you an interactive, zoomable, draggable topic map. It's time. Everything we've done, scraping, cleaning, vectorizing, was leading to this, building our very own text classifier. Let's use the sentiment labels we created earlier to train a machine learning model. Given a new headline, it should tell us if it's positive, negative, or neutral. In just a few lines, we've trained a real model. No deep learning needed. Classic algorithms like naive Bayes still rock for text. This report tells us how well the model is doing. Precision, recall, F1, score. If these are new to you, don't worry. We'll walk through it. And just like that, your model can now read a headline and tell you the mood. It's not perfect, but it's powerful. You built this. If you've made it this far, amazing job! You've just completed a full stack mini project in text mining. From crawling raw data to building a sentiment classifier. That's huge! This is a full pipeline, data in, inside out. You now have a real world text mining toolbox in your hands. Here are some awesome project ideas you can build on your own, and maybe even add to your portfolio or resume. These aren't toy projects. They're the kind of things real companies pay for. Try one, iterate, the road doesn't and end make here. It your own. This is just your starting line. You now speak the language of text. What you build next is entirely up to you. Thanks so much for sticking with me today. Don't forget to try out the code on your own. It's the best way to make the skills truly yours. See you next time and happy mining!